Hello everyone. So in this lesson we are going to try 4 different examples whereby we can really apply our special formulas for expansion and also our rainbow techniques to help us solve this expansion problem. Right. So in the first example here, we actually notice that this algebraic expression actually follows our special formula form, right? So basically we have an a plus b squared form here, whereby a is equals to 2 and b is equals to x. Okay, so all we need to do is to apply this special formula, which says that if your algebraic expression is a plus b squared, then we have a squared plus 2ab plus b squared as the expanded form. So let's apply this formula. So our a value here is 2. So when we expand, the formula says a squared, right? So it becomes 2 squared plus 2ab. A is 2 and b is x. So 2 multiplied by a, which is 2, and by b, which is x, plus b squared. B is x, so it becomes x squared, right? So 2 squared is just 4. When you multiply this term here, you will get 4x plus x squared. So that's really how you use this very useful formula to expand this kind of equations. Okay, so in the second example that we have, we can't exactly apply the formula because it doesn't follow any of these forms. It's not a plus b squared. It is also not a minus b squared. So in this case, we have to apply our rainbow technique, whereby 1 is multiplied by 3 first, 1 is multiplied by 2x next, and in another rainbow that we can draw is from negative x to 3 and negative x to 2x. Okay, so when we expand this first rainbow right at the top, 1 it gets multiplied to 3, so that is 3. 1 also gets multiplied to 2x, so that is 2x. And in the bottom rainbow here, negative x multiplied by 3, so that is a negative 3x. Negative x also is multiplied by 2x, so that gives us a negative 2x squared. So when we rearrange this, it becomes 3. Sorry, I forgot the equal sign, so you got to put the equal signs here. So 3 minus x minus 2x squared. So that's your answer. Okay, so in the third example here, we actually notice something. The algebraic expression actually follows this form, a minus b squared, right? Whereby a value is 10x and b value is 2. So we can very simply apply our formula that says that if it is a minus b squared, your expanded form will be a squared minus 2ab plus b squared. Okay, so let's apply that. So a squared, what is a squared? A squared is actually 10x. The entire term is squared. Minus 2 multiplied by a. A is 10x multiplied by 2, which is b, 2ab, plus b squared, which is 2 squared. Okay, so just box out this formula here. So a minus b squared is a squared minus 2ab plus b squared. So when you actually simplify this, 10x, the entire term is being squared, so you have 100x squared. Why is it 100? Because 10 squared is 100, and x has to be squared as well, so it's 100x squared, right? And then simplify the second part here, which is negative 2 times 10x times 2, that is 40x, plus 2 squared, that is 4. So this is your answer. Okay, and the last example that we have again does not follow any formulas that we have learned before. So it doesn't follow a minus b squared, it also doesn't follow a plus b squared. So in this case, we have to draw our rainbows out. So 3 multiplied by 3, 3 multiplied by negative x, and then the bottom rainbow would be x multiplied by 3, x multiplied by negative x. So let's expand this out. So it's 3 multiplied by 3, that is 9. 3 multiplied by negative x, that is negative 3x. And in the bottom rainbow, x multiplied by 3, that is a positive 3x. X multiplied by negative x, that is a negative x squared. So remember, when you have different signs being multiplied to each other, ensure that your sign here is negative. If it is the same sign like x multiplied by 3, both are positive, then you would expect a positive value here. Okay, so now let's just combine the like terms. So 9 minus 3x plus 3x, that's no more x terms, so it's simply just 9 minus x squared. Right, on a side note, we notice something, right? 9 minus x squared is actually the same as 3 squared minus x squared. Now if you look at this form here, it's actually very much related to your terms in these brackets. So we will talk more about this in the next video.